So let's get started with SOA. SOA stands for a service-oriented architecture. We would have known that. So it's basically an architectural pattern. It's a concept. It's nothing more than that. And it's the one I would say is that it's nothing which is born new. It was already there. It's just that they have standardized the concepts and they have given a new name to it. Otherwise, it was already there, people were using it, but they didn't put everything into place, and everything was not regularized or standardized. So SOA has brought about the definition, the concepts, the governance model, the tools that it requires. So all that forms the architecture. And it's basically trying to solve the age-old problem of developing enterprise applications. Most of before the past decade, we would have developed a lot of applications which are like web applications on the J2EE application layer, and it would be mostly a standalone application wherein we would not have integrated much things. So when we go for wider perspective of solving various business operations or the business processes that needs to be solved, we would require to develop systems that shares and talks across the systems that are developed in various departments within an organization. So SOA, what it does is it first identifies the services which can be reused or which can be, say, standalone or reusable unit of work. It tries to identify that, and then by doing that, it decouples one from other. That way, it is going to be easily integratable, and it can work with each other. And the basic criteria behind SOA working is the service orchestration. Service orchestration is the main backbone that makes SOA work. SOA is a concept, so what we are trying to achieve out of SOA is service orchestration. In practical terms, service orchestration is the one which we are trying to achieve by following the SOA practices. So we'll see what service orchestration is all about. So the backbone of SOA is a service. So what a service is? So a service is nothing but it's a self-contained reusable piece of software. So whichever can be defined and then a particular task should be executable by a small program. So that is going to be a service. It's analogous to what we call in the class. A class becomes good, becomes perfect when we are able to contain the class to a particular functionality or particular task that a class will be able to carry out. So in the similar way, service is also a unit of work that can be self-contained and which can be reused across functionalities. So that's a service, and which achieves some purpose in the business terms. So this service can be, this service will be having an interface exposed, and the communication with this service will be through that interface, and the implementation of the service is going to be hidden from the external world, so that when we want to change it, we are going to change the implementation. And the other applications wouldn't even know that the service at the back had changed, because it's going to always deal with that service through the interface. So on a whole, it's this is how the definition goes: is a self-contained reusable unit of software which can execute a particular task. So here, for example, I have given that retrieving your bank account balance is one example of a service. It's so this is retrieving your bank account balance is one particular functionality. That's it. So this will be self-contained, and we can use this functionality wherever we need this particular service. Wherever we need to retrieve the bank account balance of a particular user, we would be able to use this service. Okay then, so what service orchestration is all about? Service orchestration is nothing but integrating more than one service and making in trying to automate a particular process. If there is a business process, let's say here an example I've given, it's an insurance claim application. If it's a claim application, then we need a set of steps that needs to be carried out for this operation to be done. So these set of tasks that needs to be carried out should be divided into different services, which are all self-contained and which can be plugged into various functionalities. So in this case, it's an insurance claim application. So let's assume there are 4 activities that we have. One is we need to search the customer. Next is we need to check whether the claim that is there is a valid one. And third is we want to check the balance. Fourth is we want to debit the balance if the claim is valid. So these are the 4 activities that we are going to do. So this orchestration is going to be done by the SOA based platform, whatever you decide. It can be a custom built platform, custom built application following the SOA concepts, or it can be an ESB which is going to orchestrate this whole process. It can be anything, wherever, but at last the thing is, the platform that you are building should be able to capable of allowing services to be plugged into it, and should be capable of making these services talk to each other, making these services to be invoked in a platform agnostic manner, and also this should be capable of talking to distributable service. It's not that each service has to be deployed in the same server or the same organization. Each service can come from different geography, different organizations, and different platforms and different services. So the SOA based integration platform, the below box that we see, that thing should be able to, whichever a product or tool that we decide, or it's going to be a custom developed one, that should be capable of all these functionalities. So here in the case, when a client sends a request, so these 4 services are going to be orchestrated in the sequence of activity, in the sequence that we have pre-configured it. So each service would provide its own data, and then it will not even know why the data is being sent, what is the next activity. These are all 4 different services which are just plugged into it to solve a particular problem. Here in the case, it's to solve the here in the case it is to adjudicate the claims process, meaning to process a particular claim that has come to the system. So this is a very high level overview of what a service orchestration is about, and all that we are going to do going forward in ESBs, when we actually go into Mule ESB and start developing the applications, it will be service orchestration that we are doing. And then so why do we need SOA? Why everybody is going for SOA? We saw most of the things, but let's go over it. So when we think in terms of SOA, basically it's a concept. It's basically a way of thinking in the organization that needs to be developed when we talk about SOA, more than the tools and the technologies that we have. When we talk about SOA, it's more on the thinking terms, more on the way we design the applications. So at first, when we try to implement SOA in any of our applications or in any of our departments in the organization, we need to identify the systems or applications which can be broken down into services, which can be, when we say services, again, it should be self-contained one and reusable one. So we need to first step in going for SOA is it identifies the systems and applications that can be converted into services. So by doing that, we would be able to, we enhance our we enhance maintainability, we enhance scalability, we enhance a lot of features within our organization, wherein we would be able to meet the demands of our changes, business changes, more smoothly. So it adds to that, and it promotes using standards. If the other thing is that nowadays everything is moving towards standard based, so that we are able to use more open standards. We have a lot of solutions available open source, as well as the vendors like IBM, Oracle, and all these people, they also provide products based on these open standards, and so that we are not logged into any proprietary concept or a technology or a tool which follows their own language, which follows their own standard. We don't fall into that trap. So SOA promotes using standards which are all open standards, and mostly we have solutions both from a vendor perspective, also from a open source perspective. So this is very critical when we go for integration terms, because we don't want to lock our systems to any particular vendor, any particular proprietary language or platform there. So that the platform is common. Basically the standards might be a example for XML we will have, or we'll have the JMS standard. JMS standard is very important when we have various applications, when we want applications to work asynchronously. So in those cases we need JMS. And then as we know, SOA enhances integration capability, so that we can plug and play our services, and then if you want, we can update services without even the other systems that are talking to each other wouldn't even know that the service got updated. So the changes can be maintained more easily with less, I would not say nothing, but less changes affecting on the other clients or the consuming services. At last, whatever it is, any software pattern or concept or anything new that comes is all going to deal with the old concept of loose coupling in the software engineering. So loose coupling, if you see even all the object-oriented principles or this SOA, for instance, everything is at last going to be concentrating on how do we achieve a loose coupling within the systems and applications that we develop, the services that we develop. So when we have this loose coupling achieved, we achieve a lot of things, like we achieve reusability, we can extend it, we can maintain it easily, the cost comes down, and we can change it easily, we can plug and play. So basically SOA is also about how do we decouple and first identify and then decouple the functionalities into services, and then plug and play and make them talk to each other. So that's what it tries to do. And and the other thing is, here I've given some organizations are not willing to give up their tried and tested technologies, but the truth is that it's not willing, it's they cannot give it up. So one of the clients that I work is mostly on the insurance side, and for him the whole logic is in the legacy application, the mainframes application, and there is thousands and thousands of programs there, and they would not be able to migrate that application even if they wanted to, because it is developed like 20-30 years back, and people have left the organization. Nobody has the business knowledge to go ahead and migrate those applications, so they're stuck with the legacy applications, the mainframes. Even though we have the latest technologies available to solve their problems, they would not be able to migrate all that user base, all that data, all that financial data to a newer system, and then without affecting their business. And it might be that after putting a lot of effort, it might go down as well, the project might go down as well. So that's the reason that the reality is that we need to work with systems that are old, that are having technologies that are old, and then which are not easily interoperable with the technologies that we have as of today, nor it follows the SOA architecture or the new architectures that have come up. So it is the responsibility lies with the new architecture that makes the new application to talk with the older application. So the responsibility lies with the new application that we develop. So when we go for SOA, the thing that it does is, when we are developing a new application, the thing that it provides is that it provides a capability to connect to the older application. Added to that, it doesn't allow us to worry about we are going to integrate with an old application. We can still go ahead and develop our application with the business logic that we need to do, regardless of the fact that it is going to be integrated to a older application. So that decoupling is what we are talking about. We don't have to develop the application with the full knowledge that we should have to do this integration. So what are the things that we need to develop specifically for that integration? When we follow SOA architecture, we don't have to think about that. Whatever SOA platform that we are going to use to implement the SOA architecture, that's going to do that activity of worrying about how to integrate the new application and the older application. New application itself is going to be a self-contained reusable component or a service which is going to talk to the older application. So that's what it actually provides us. That cushion it provides us. We don't have to worry basically how do we do it, or if tomorrow a separate application comes which needs to talk with this particular application, we will not worry. It will talk seamlessly in a very smooth manner. So that is why people are moving towards SOA, because it provides all these capabilities. And when we talk about advantages, applications are loosely coupled, we know that, and then it provides us location transparency. Location transparency, when we talk about location transparency, when we take SOA concept itself, it's more for a distributed application. The services in an organization, or let's say the services that a particular application needs to consume, regardless of whether it's in organization or outside the organization, can be hosted anywhere in the world and in different geographic locations and different platforms as well. So when I try to consume a service, when I try to hit a service, I will just know I will be hitting the service just like any other ordinary local service that I want to consume. And it's the SOA's, whatever platform that I have built, it is a responsibility of that platform to go ahead, find the service from from a list of servers that provide that particular service, and then appropriately go and hit the server which is having less load at that particular point in time and get me back the response. So I myself will not go ahead and give a direct request on the I would not even know where the service is hosted. That's what location transparency is about. So by this way, I would not have any knowledge except the way to invoke that thing, and there will be an intermediate component. It might be an ASB, it might be any SOA platform that we have decided, which hosts all these services, or which host a connector to these services, and that does the job of connecting to the actual service provider and then gets the response back to us. So location transparency is more of hiding the hiding the place where the service provider is hosted or where the service is coming from. I don't even have to know about it. I will just know that when I hit the service, I'll just get a response back. Third thing is reusability. We would have a look at reusability in more detailed terms in the next few slides. And then we have this improved testability, since the services are decoupled from one another. It makes much more sense that we would be able to test that particular service in a more like we can test it more thoroughly than if it was attached to a particular application, and if that application is a monolithic application which provides various functionalities and each one is tightly coupled and dependent on each other, then testing a functionality is going to be much more difficult than when we are going to test in a functionality when it is loosely coupled and decoupled from all the other services. So it improves. And high availability. So high availability, whenever we talk about availability, it is about having a cluster. It is about having services in a redundant fashion. Availability comes only when we have services deployed in multiple servers, and when in multiple servers, and the servers can be in a distributed fashion. It can be in different locations. So since the service is a limited one, it's a self-contained piece of code, it can be deployed in multiple servers, so the deployment effort is not going to be huge. So since it's not heavyweight, it's lightweight, so it can be deployed in multiple servers without much effort. So that improves high availability, because we can distribute the servers in which these services can be deployed, and we can improve redundancy because it's lightweight. It does not require a huge deployment effort to deploy that particular service. So all these features add on to the high availability. And next we move on to the scalability. scalability is more in terms of when we increase the load, how does our servers capable of handling the load. So whether we are able to scale our services as the load increases. We will also have a look at what is horizontal scaling versus vertical scaling and all that. But basically, since the application at last, we again come to the same thing, since it is decoupled, we would be able to increase the redundancy of the servers, or we would be that's the horizontal, or we would be able to increase the power of a particular server, that's the vertical scaling, and then we would be able to make the service scalable. So these are all the basic advantages that we derive out of SOA.